Good afternoon, everyone, or good evening. My name is Marlon. My presentation is going to be on Module 7. Here are some key points on this presentation. I'm going to be talking about short run, minimizing costs, long run. There's a lot of important terminology in this section. There's an equation. I'm going to give a real life example, and I'm also going to provide a graph. Okay. Now, I could read all of these thoroughly. These are the definitions that I found on the book, but just to sum it up, because we have a lot to cover. Variable cost is basically a cost that can be moved around. The price can go up and down, right? A fixed cost is more, in a sense, something that can be moved. It's more as like a rent or a lease, or you paint something and you can't, actually that's sunk cost. I'm so sorry about that. Now opportunity cost means, hey, that's where fixed costs could kind of move around. Let's say you have a lease for 5 years and somebody, at, let's say, $2,000 a month, and yet somebody offers you, hey, I'll give you a month-to-month lease at $1,000 a month. You take that as an opportunity cost, switch to your fixed cost for an opportunity cost. You could do that as well. A sunk cost is something like paint. That's what the book gave a good definition, and it makes sense. Once you put paint on something, you can't take it off. Depreciation. If you're familiar with accounting, your assets, they have a depreciation cost or depreciation that goes down with them. For example, you buy a truck for your company, a tow truck, you buy it for $110,000, a brand new one. And you can say each year depreciates about, let's say $10,000. You have a lifespan of that tow truck for being 10 years. And at the 10th year, most likely you're either going to have to replace it and or sell it for a new one. Now, your short run cost minimization. This is the firm's way of minimizing costs and increase revenue. This is also trying to lower costs while also trying to increase production. Now, the long run costs is the same thing, but might end up saving you more money than short run, because you have some fixed as liabilities and some variable. ISO cost line is a graph of every possible combination of inputs that yields the same cost production. Now here you have the equation for production function. You have Q equals F inside parentheses LK. And you can see I labeled it out for you. Q is the output, L is labor, capital, K is capital, K with, I don't know the terminology, but with the line on top, that is fixed capital. Now you have the Cobb-Douglas equation, which is one way of short run cost minimization. This shows you that solving the equation for L or K gives cost minimization level of labor or capital. Every level of output is known into the input demand function. Now in the bottom you can see you're solving for L or K, and this is how you do it. Now a real life example would be John, the owner of a flashlight producer company, has a target output of 2,000 flashlights. The labor costs him $15 an hour, and his capital cost is $3 an hour. What is the most cost-effective mix of labor and capital to produce the larger output of 2,000 flashlights in the production? So you set up the equation Q equals 10 square root to the fixed capital and labor. So CQ equals WL plus RK. Labor, L equals labor, K equals capital, W equals wage rate, and R equals rental cost. CQ equals total cost. Now, then you have, first we need to find the marginal production of the labor and capital. Then taking the ratio of the marginal product and labor over capital, we get the ratio of capital hours over labor hours, which is also equivalent to the ratio of the wage rate and the rental rate. Substituting the wage and the rental rate and solving for capital, we see that capital is 5 times more costly than labor. Sorry. Now you can see MPL and MPK. This is where you're finding the equation for labor, and right here you're finding the equation for K, and you get MPL over MPK, which gives you WR, what equals to K over L, which equals to WR. Now you got your wage rate over your rate, and that gives you that -5. K over L, gives you -5, which, as I stated right there, 5 times more costly than your labor. Now, since John's target is 2,000 flashlights, substituted into the product function and solving, we can find out the most cost-efficient way for him to meet target output is 40 labor hours and 200 capital hours. So this is where you do 2,000, which is the total amount of flashlights he wants to get, and he said equal to 10 equals 10 labor to the half, k to the half. So what you end up doing here is you end up doing the derivative for k. So then you got 5L equals 200, k equals 200, L equals 40. All right. So knowing this, we can use the equation below to find out how much total cost would be to meet the target output of the most effective hours of labor and capital based as the given values. So we get right here, the output equals 15L plus 3K. Using the same as before, K equals 5L and L equals K over 5. We can substitute these into the original production function. Q equals 10, square root of fixed capital times labor. We get LQ equals Q all over the 10 square root of 3, and KQ, which is, sorry, I always get that, capital output equals square root of 5 all over 10. Substitute into the original cost function and solving, we get output equals 3 all over the 2 square root of 3 output plus 3 square root of 5 all over 10 to the output. Plug it into John's target output production. We get this total, which is output equals $3,073.69. Now we need a graph, and the best graph that's going to represent this is the ISO cost line output. This represents the ISO cost line and of the varying minimizing labor and capital inputs for a target output of 2,000 within the given rates. If this rate, such as capital or labor, were changed along with different target output, then we would have a similarly sketched graph, but with a different minimizing outputs, depending on how high or low the target output is. Now, I'm sorry, I tend to start a lot, but this is the end of my presentation. If you have any questions, feel free to ask me. Something that you didn't understand, just let me know. But anyways, I hope everyone has a great weekend, and thank you so much.